Hey guys, this is Jur. I'm an intern at Great Lake Studio, and we recently bought a Behave 2.0 library from the Unity Asset Store. And if you're not familiar with behavior trees, then you should check it out online because it's a very powerful tool. There is loads and loads of information online, but it's too big for this video to cover all of it. So this would be a great time to check it out because apparently you're interested in behavior trees. Now, with Behave 2.0, it's very easy to create new behavior trees. Yeah, so let's get to it. First of all, of course, you should create a project and drag the library inside. Once you did that, you should be able to create a new Behave window, open it. And once you open that, you pretty much see nothing, which is because you should first create a new Behave library, which I already did, and it should look a little bit, whoops, like this. And if you open that, you have this view. So you have an agent blueprints, and then you have a trees tab and some other stuff. First of all, what you want to do is create a blueprint. And the blueprints are just like folders in Windows Explorer, in that you can have multiple blueprints and each of those can have multiple trees inside. And this is nice because I might want to have also a cat behavior blueprint, and then I also want to have a goldfish behavior blueprint, and I don't have everything in one big ugly pile. And so it's divided into nice little separate blueprints. What I want to do is to click mono behavior derived because I want to add it to my little cube. And so I want to access its game object, and I want to create a coroutine and all that stuff. So you should check this little mono behavior derived checkbox over here, and then create a new tree with a little plus sign. I already did so I'm going to delete this again. But once you created a new tree, make sure that you also check it over here so that it is actually added into your newly created blueprint. Now, here I have my little tree which I already created, and in this part I just want to talk a little bit about the basic behavior or the basic fundamentals of the tree itself. I want to talk about behave types, which are pretty much like states. Then I want to talk about the different control nodes and action nodes, and I want to talk a little bit about the sequence of iterations that is going to follow. Now, first of all, behave type, as I said, is more or less like a state. In that, like in this state or in this action, I tell the dog to walk outside, and if it was successful in walking outside, it's going to return a success. If something was in the way, for example, the door was locked and it couldn't be able to walk outside, it's going to return me a failure. And finally, if one iteration wasn't enough to walk outside, so for example, the house is too big, I'm going to it takes more iterations to walk outside. He's going to return me a running. And success and failure are pretty self-explanatory. Running as well, but it sometimes adds up to other behavior than very self-explanatory in that way. So I want to also be talking about the running statement a little bit later. First of all, before I do that, I want to talk a little bit about the control nodes, because there's a difference between control nodes and action nodes. Action nodes are actually the only executables, so these with the little exclamation mark can be executed by the control nodes. And I say by control nodes, that's because a control node is going to dictate in what sequence these actions are going to be performed. So we have different control nodes. So this is a selector node, And what it does is it's going to walk from left to right through all of its children, and it's going to check whether or not this action could be, or this branch can be executed. So if it returns a failure, then it says like, okay, so you were not able to walk outside. I get that, but why don't you try to find the burglar and then bite the burglar and so on, until it reaches every last child. If none of the children return a success, it's going to return a failure in the end. So none of its actions were able to fire, or at least successfully fire. But if I return success, for example, I was able to walk outside, then I'm going to stop, and I am going to return a success as well. So a selector basically just keeps running until one of its branches returns a success, and then it's going to stop. Now, a sequence does about the same, but a little bit differently, because it's going to run its children and try to fire them, or try to handle them. And every time a branch returns a success, we are going to the next iteration. So where a selector stops at a success, the sequence is going to go to the next branch in its child branch list. So also from left to right. And when a node fails in succeeding its task, then we are going to stop. So it's actually the opposite of a selector, in that it's going to run until one of its children returns a failure, and then it's going to stop. Now then we have a interrupter, which actually is more or less like a if statement. It's going to check its control node, which is on the right side, and it's going to try and find a burglar. So if this returns a success, then immediately we're going to try and bite the burglar in this case. And if it returns a failure, then we're going to do nothing and return a failure as well. So in that sense, it's like an if statement that only if this executes with a successful statement, so with a successful return type, we are going to bite the burglar. But obviously we cannot bite a burglar if we cannot find one, so we're going to return. Then we have the repeater. What it does is it's going to swag its tail, so it's not going to check first. It's going to do its stuff, so it's going to swag its tail, and next stop it's going to check whether or not it can bark. And if it can bark, so if bark returns success, then we are going to return a running, and during the next iteration we again are going to swag our tail and then check if we can bark. And we're going to do so until bark returns a failure, in which case we will return a failure as well. Are we returning failure? Well, we're going to stop anyway. So I'm not sure if it returns a failure after barking, but I will look into it. I'm sorry for now. Anyhow, then we have the priority selector, and it's basically like the selector, only where the selector goes from left to right to check all the children. The priority selector is going to, you can specify in which sequence it is going to check its child branches. So we might want to check howl first, we also might want to check run first. It's completely up to the programmer to dictate in which sequence we're going to check its child branches. And other than that, it's completely the same as the selector. And then finally we have the parallel, and what it does is it's going to run all of its children at the same time. So where a sequence runs a child and then waits till the next iteration, a parallel is going to run its left child and in the same iteration run its right child afterwards. So basically at exactly the same moment but with a few milliseconds delay. And it has some other properties as well, but I want to get into that later. Now, there are some more functions to most nodes. The parallel I'm going to talk about later, but for every action has a what do you call this? It is going step versus instant. Step means that he's going to wait until the next iteration. So sorry, let's pick a nice one. Okay, here, walk outside. This has a step versus instant, and what it means is everything is default step. So we're going to check. If this fails, then during the next iteration we are going to check our second child. But if we select this, so our instant, if we toggle that to true, we are going to check it. If it returns a failure, then instead of waiting for the next iteration, we are going to immediately check the second child. So normally we wait one iteration before checking the second child. Now we are going to immediately go through once this one fails. So that is the difference between step and instant. And then we also have the difference between standard and inverted. And what it does is standard, then success returns success and failure returns failure. But with inverted we can change that. So actually a success would return a failure and vice versa. It does not have effect on the running state. Now, before we go on, we should first save our changes, so apply changes. And what it's going to do is going to create a few or generate a few classes for us. And these classes we can derive from, and we can receive updates from the tree. So apply changes. Right, thank you. And yeah, it's going to do something, but never mind that, because our build was successful, so it doesn't really matter. Now I already created a dog behavior script, and I added it to my little dog cube here. It's a cubey dog, and open that. Now shut up. Now what we want to do is use the behave.runtime, which is basically like the base package of the behave. The package of the behave library, excuse me. And then we are also going to use a tree. Now, because Unity Engine also specifies a tree, we want to make sure that the default is set to the runtime or the behave.runtime.tree. Otherwise, we would get some weird exceptions. And then we are going to derive from the bad dog, but BA actually stands for behave agent, and then dog behavior underscore dog behavior blueprint, which we created. And it is a tree, so it is a behave tree. And in our coroutine start, and at this point I should point you to the fact that it might be very useful to, if you are not familiar with coroutines, go check it out as well, because it's a very useful and powerful tool, and it's going to be used a lot, frequently. Now, in our behave library dog behavior tree, which is a mouthful, we're going to instantiate that tree that we just created here, or just oh well. And this is actually the only way to instantiate a tree. And what we do is we give it two parameters, namely the type of tree that we want to create, and then also ourselves, so the dog behavior script, which is going to function like the agent, and it's going to receive updates from the tree. And now we're going to create a nice while loop in which we can tick our tree. So application that is playing, so as long as the application is running, we are going to tick the tree. That is our job as designers. And if it's not still running, so if it's not in the process of doing something, then we should reset it, because it's going to run and its values are going to be changed, and unless we change them back, then they are going to forever be changed, and we want to start with a fresh tree every time it is completed. So that's what we do the reset for, and then of course we want to yield return and do this every 5 seconds or whatever we specify. In this case I do 5 seconds because it's a little slowly and you can see what it's doing. Now the code isn't really nice, all of which is randomized and it's not really cool, but I can run it for just wait, let me set it actually to 1 and we can look at it later, but the chances are that it's going to be not very nice. So he failed to go outside. Now he found a burglar, but he couldn't bite it. So, and he failed to go outside. It's actually kind of a stupid dog. Oh well, it succeeded in going outside. Anyway, so it's stuck at this thing for a long while, because if this succeeds, then it's going to reset. If it keeps running, it's going to keep on walking outside, and if this fails, so there's actually a small chance that he ever gets beyond the point of biting a burglar or even trying to bite a burglar. So yeah, maybe next time we can create a little nicer tree, and I hope you will be with me. And for now I wish you a good day and good luck with the engine.